Okay, so here's just a quick fun fact. Here's a list of whole numbers that satisfy Pythagorean theorem, and these are called Pythagorean triples. All right, and what's so great about Pythagorean theorems? They're just whole numbers, work in Pythagorean theorem. So like a squared or 3 squared plus 4 squared equals 5 squared. That's the first one right here. That's the most famous one. Or you can even look at this one right here. This is a Pythagorean triple because 35 squared plus 612 squared equals 613 squared. That's kind of interesting. I would have never guessed. All right, and there's an infinite amount. All right, so they're just whole numbers that satisfy Pythagorean theorem. So if it asks you, is this a Pythagorean triple? Just plug it into Pythagorean theorem, and if it works, then the answer is yes. All right, so this is what I was kind of talking about. What's cool about some of the stuff we talked about above is I can classify this triangle by angles and sides by just knowing the side lengths. All right, and what do I mean by that? Well, one, we got to check the triangle inequality. And what do I mean by that? We have this in Unit 5, where the two smaller side lengths, in this case right here, A plus B, has to be bigger than C. All right, don't forget about the triangle inequality. That still must work. So in this case right here, it's going to be 8 plus 15 is greater than 20. 23. All right, so cool. It's possible to make a triangle with these side lengths. We first must check that. All right. 2 is we're going to plug it into Pythagorean theorem. And now what I'm going to do, what I like to do, is say, well, a squared plus b squared blank c squared. All right, I like to leave a blank. Don't write equals or any of that. Let's see what just happens. All right, so let's go ahead and plug in things. We're going to have 8 squared plus 15 squared, and we're going to compare it to 20 squared. All right, doing some bashing in my calculator off screen. 8 squared plus 15 squared is 289. All right, 20 squared is 400. All right, so I left it blank. Now I can identify, well, 400 is bigger than 289. All right, and this might take some memorization or some just thinking or some logic, but we got to use these facts up here. So we got to know that if a squared plus b squared is less than c squared, it's obtuse. Or a squared plus b squared is greater than c squared, then it's acute. We have to memorize that. So in this case right here, a squared plus b squared was less than c squared. So we know this is an obtuse triangle. All right. Now what's very powerful, what's really cool, is we can classify this whole thing. I'll write it over here. This is none of the sides are the same. So it's scalene. None of the sides are the same. Scalene obtuse. Pretty cool. All right. So that's how we do it. Now we're just going to do the same thing over and over again. All right. We got a bunch of examples. All right. So again, I'm going to write triangle inequality. 7 plus 24 is greater than 25 because 31 is greater than 25, so it checks out. Also, something we can already do is 7, 24, and 25. All of them are different side lengths, so I already know it's scalene. I already know that. Now I just got to confirm, this is what's a classification by angles? So now I'm going to do Pythagorean theorem. So TI, triangle inequality, PT, Pythagorean theorem, 7 squared plus 24 squared equals, or no, remember I like to leave it blank, blank 25. All right, squared. Don't forget the squared. 7 squared plus 24 squared is 625. 25 squared, OMG people, is 625. So this is a Pythagorean triple. These whole numbers worked. So since Pythagorean theorem worked, it's a right triangle. So it's a right scalene. scalene right, right scalene, however you want to phrase it. All right, so repetition, so much fun, repetition. Let's see, looking at this, we got 9, 9, and 10. Two sides are the same, so remember that's isosceles. You should know what that means by now. If you don't know the difference between scalene, isosceles, and equilateral, that's just a choice on your part. Sometimes you just got to memorize things, all right? Now, the triangle inequality theorem, TI, well, the two smaller sides, 9 plus 9, must add up to be greater than 10, which it works, it checks out. All right. Next is the Pythagorean theorem. We're going to get 9 squared plus 9 squared blank 10 squared, which is going to give me 162 and 100. So we haven't seen this case till right now. We have 162 is greater than 100, so this is acute. When a squared plus b squared is greater than c squared, remember it's acute. All right, just got to memorize it. Got to know what's going on. So isosceles, acute, acute isosceles, however you want to phrase it. All right. Keep cruising. How are we doing on time? We'll just do a couple more. Maybe I'll delete some of these. Triangle, first off, let's just do triangle inequality first, all right? 6 plus 7, because remember, we picked the two smaller sides. 13 greater than 14, that's not true. All right, so triangle inequality theorem failed. When that fails, it's not a triangle. All right, and then to save some time, I'm just going to write down the answers to these. You guys can try these on your own. But if you leave these blank, I know why. This is acute isosceles. And this is scalene. I think this is obtuse. All right. You guys can do those problems for fun. Just check your work on your own. Get a little extra practice. But to save some time, I spelled scalene wrong. Gonna not do those on screen.